And just like a few starter problems. Just says sketch the curve and eliminate the parameter.
Okay.
So x equals root t and y equals 1 minus t.
Okay. How do we eliminate the parameter?
We find, or just find what t equals.
Yeah. In other words, solve for t for both equations, and then you'll be able to set the one side equal to the other. So here, t is equal to x squared. Over here, t is equal to 1 minus y. Well, it's the same t. So if t equals x squared and t equals 1 minus y, then x squared equals 1 minus y. No more parameters.
Mm-hmm.
As far as graphing it, well,
Mm-hmm.
that means y equals 1 minus x squared. We know how to graph that, right? In other words, that's an upside down parabola that's been shifted up 1. Upside down parabola would be that. Shifted up 1 would be that. Now,
is that the same?
We graphed it after we had eliminated the parameter.
Mm-hmm.
So just for the heck of it, let's go back and try graphing it with the parameter.
Okay.
It was y equal 1 minus x?
1 minus t, yeah.
1 minus t, excuse me.
Yeah.
Did it give any conditions on t at the beginning of the problem?
No.
Okay.
We usually just do it from -2 to 2.
It did say that. Okay, -2 to 2. That's important. Parametric equations actually have an additional restriction on them. It's not just 2 equations with a third parameter in there. It's that third parameter usually has a very specific domain. In other words, t only goes from -2 to 2. What is the x-coordinate when t is -2? Aha, we got problems. It's not defined. You sure that t goes from -2 to 2?
Yeah.
Okay. Well, we obviously have a problem at -2. We can't take the square root of a negative number. So if, nor -1, if we let t equal 0, then the first point on our curve is right there. That's our first point. When we let t equal 1, we've got x equal 1, y equals 0. Well, where is that? X equal 1, y equals 0 is right there. So there's the second point on our curve. When t equals 1, x equals, I'm sorry, we just did that one. When t equals 2, x equals the square root of 2, and y equals -1, which is that part on the curve. In other words, as I go through the range of t values, I basically can make a table. And we've got t, x, and y. And generally, I'd go -2, -1, 0, 1, 2. But they've thrown me a little bit of a curve here by making t go from -2. Because it seems to me like that violates this domain all day long. It doesn't violate this, but then t isn't in that. So we don't have any restriction on domain once we've removed the parameter. We can draw it completely. But stepping through t for parametric equations is required. I don't know why they've started you off with one here where you had to take the square root of a negative number. That seems a little strange, but what's the next problem?
X equals t minus 1 and y equals t over t minus 1.
Okay, solve the left one.
T equals negative 8. Yeah.
Okay. This one's a little harder to solve. How do we solve this one for t?
Just multiply both sides by t minus 1.
Okay, now what?
Back. No.
Distribute.
Yeah.
And bring the other t over to this side. And bring everything without a t in it to the other side. Remember, we're solving for t, not y. So now how do we solve for t? What's my next step?
Take a t out of the left-hand side.
Excuse me. Sneezing threes. So t equals y over y minus 1, and t equal x plus 1. So now we have x plus 1 equals y over y minus 1. And guess we can stop there. We've removed the parameter. We haven't simplified the equation. And I could solve this for y in the same way that I solved this one for t. Notice that I solved that for t. That looks real similar to this problem over here, and I would solve it the same way. In other words, multiply both sides by y minus 1, gather all terms with y on the left, everything else on the right, factor out a y, divide by the coefficient. And whether or not they want you to do that or not, I'm not sure. Do you know? Are you supposed to end up with y equals?
I think we're supposed to end up with y equals so we can graph it.
Okay. Let's solve that for y. Tell me what to do.
Multiply both sides by y minus 1.
Okay, so we got x plus 1 times y minus 1 equals y. This is xy minus x plus y minus 1 equals y. Well, now we got a y there and a y there. Leaving 0. So now I got x, y. I'm putting everything on the other side that doesn't have a y in it. Now, for graphing that, you know how to graph that?
No.
Well, let's turn it into something a little more recognizable. And more recognizable still, what's the elementary function? If y equals 1 over x plus 1, What is my elementary function? And let's graph this based on it being a translation.
I equals 1 over x.
Move everything up 1. By moving that horizontal asymptote. Now, let's look at the original. Now, was that t goes from -2 to 2 for all of these problems, or did this one have a different set of?
No, it's the same.
T goes from -2 to 2?
Yeah.
Okay. Notice that we're going to violate the domain when we get to 0.
Mm-hmm.
Okay, so let's look at the original equations. What was the first one? X was equal to what?
X
Hold on. Do I have it up? Yeah, here we go. Here we go. I thought I had erased it all. There were just so many steps. So x equal t minus 1 and y equal t over t minus 1. Well, again, we're going to have problems when t is 1.
Mm-hmm.
Right? So t is not going to be able to go from -2 to 2. It's going to have to skip 1. So the effective domain on t is -2 to 2, but not 0.
Mm-hmm.
The domain gets a little tricky on these parametric equations. There can be some unusual situations where the domain excuse me. I was gonna yeah, the domain can get a little tricky on these parametric equations.
Mm-hmm.
But in terms of graphing, if you graph a parametric equation, let's see, is x restricted to positive here? No, because when t is -2, x is -3. So we're on both sides of the y-axis here. When I put a graph up, that graph is one equation, 2 variables. But if I put the parametric graphs up, it's the same thing. In other words, it's just a different way of defining that graph. The other difference with parametric is there is an arrow on the graph.
Mm-hmm.
And I didn't talk about this in the first problem, but let's talk about it here. When t equals -2, where do we begin? Well, when t equals -2, x is 3. So x equals -3, excuse me, and y would equal -2 over -3, 2/3. So when x is -2, when t is -2, x is -3, and y is 2/3. Well, that's about right there. Okay, that's -3, 2/3. That's our first point on the graph. Now, when we let t equal -1, x becomes -2, and y becomes 1/2. So x becomes minus 2, y becomes 1/2, and the arrow goes this way. Not a very good arrow. Let me try that again. In other words, as I count down my t's from minus 2 to 2, I put a dot on the graph and draw the arrow in the direction that I'm moving.
Mm-hmm.
Now let's keep going. When t is 0, x is minus 1 and y is 0. So when t is 0, x is minus 1, y is 0. That's when t is 0. Okay? Mm-hmm. Now, t can't be minus 1 because it violates the domain. So we're going to skip that. I'm not quite sure what that means, what the consequences of that means. I may have to do a little research on this to clarify that. T can't be 1 clearly, but t can be 2. When t is 2, x is 1 and y is 2. So when t is 2, x is 1, y is 2. About right there. X is 1, y is 2 when t is 2. And that's the only 4 points we have. If we're going to let t go from minus 2 to 2, it doesn't trace out this whole curve. It doesn't trace out the exact same curve, y equal 1 over x plus 1. It only traces out 4 points on it. This one, this one, this one, and then this one. These 3, we can tell we're going in this direction. This one, I don't know. It's probably going in the same direction if I let t keep increasing, but I'm not even sure you can let t keep increasing. When they define the domain of t, that's it.
Mm-hmm.
So the graph might actually just be, if I'm graphing the parametric equation, do you have answers for these by chance? Do you have in the back of the book what the graph looks like?
Not for these ones because they're evens.
Oh, okay. Let's do an odd so we can look at their graph and see if their graph only shows 4 points, okay, or whether it shows the whole curve.
So x equals t plus 2. Y equals t squared.
That it?
Yeah.
And t still goes from minus 2 to 2.
Yeah.
And there's no domain violations now. Not yet. No, there's still not going to be. So we got t equal to x minus 2, and we got t equal to plus or minus the square root of y.
Mm-hmm.
So now I got x minus 2 equals plus or minus the square root of y. Square both sides, we got x squared minus 4x plus 4 equals y. So there's our eliminating the parameter answer. Doesn't look like there's any domain restrictions on that.
Mm-hmm.
That is x minus 2 squared, which is a parabola moved 2 units to the right. So it's going to look like that if I graph the xy function. Now let's see what points show up when I count t from minus 2 to 2. Well, when t is minus 2, x is 0 and y is 4. So there's 1 point. When t is minus 1, X is 1, Y is 1. So we're heading in this direction. When t is 0, x is 2, y is 0. When t is 1, x is 3, y is 1. And when t is 2, x is 4, y is 4. So we should get this much of the curve only on your answer. We should get a parabola that starts at 4 and goes down, touches the x-axis, and comes back and ends at 4. I'm curious what the book shows. Does it show the book should show this much of the curve with an arrow going that direction and this direction.
Yeah, I'll check it.
Yeah. Just so we'll know what they want.
Yeah, that's what it shows.
It does. Okay. So it doesn't show this part of the curve or this part of the curve.
Actually, well, it just continues the graph, so.
Oh, it does. So it shows the full graph of this, of y equal x minus 2 quantity squared.
Yeah.
Does it have the individual points for when t counts from minus 2 to 2?
No, it doesn't show those.
But it has the arrow?
Yeah.
Okay. All right. Well, interesting. Okay, so now we know what they want. All they want is the graph of the xy equation with an arrow pointing how it gets drawn as t counts from the lower number to the higher numbers.
Mm-hmm.
If you put in this parametric equation into your calculator, you'll see it draw it, and it'll draw it like this. In other words, you'll actually see it go like this. And I'll bet you it doesn't draw the whole curve. I'll bet you anything, if you put this in as a parametric equation into your calculator, it does this. And you'll see it draw, and it'll stop right there. Because when you define this parametrically into your calculator, you put that in, you put that in, and you put t goes from minus 2 to plus 2. All right, what else you got? We got 6 minutes. Unfortunately, I have an 8 o'clock tonight also. Somebody else catching up. Calculus student.
Okay. Mm-hmm. X equals 3 cosine of theta. Y equals 3 sine of theta.
Not so easy to solve for theta. Theta being the third parameter here.
Mm-hmm.
I mean, I could solve for it by taking the inverse. So I'd have the inverse of this and the inverse of that. But that's not going to make it very easy to graph or handle. There's a trick to use here. That is, square both sides. It's been a while since I've done this. I got to remember how this works. So now we can certainly add two equations together, right?
Mm-hmm.
So I got x squared plus y squared equals 9 factored out cosine squared plus sine squared. Now I can eliminate the parameter because that's equal to 1. So my result is x squared plus y squared equals 9, a circle of radius 3. And what does it say about theta? Goes from 0 to pi, right? Not 2 pi?
Yeah.
That's because the circle will be traced out by the time it gets to pi. If you go 0 to 2 pi, it'll trace it twice.
Okay.
And that's because if you work it out, your first point when theta is 0 is there. X is equal to 3, y is equal to 0. And it's going to trace it out counterclockwise. It's going to get to there by the time we get to pi over 2. And by the time we get all the way to pi, makes one trace of the circle. And if we did it 2 pi, it would just trace it a second time. So, yeah, these are a little tricky when you have cosine and sine. You don't solve them quite the same way. In other words, we don't solve this the way we solved all the others. I'm curious as to what the heck would happen if we tried. Would we still come up with a circle? I don't think so. We'd have theta equals the inverse cosine of x over 3. And here, theta equals the inverse sine of y over 3. So now we have the inverse cosine of x over 3 equals the inverse sine of y over 3. Man, I don't know what we're going to do with that. So you can see the problem.
Yeah.
If you try to solve for theta like we tried to solve for t before, it doesn't work so well when you have trig functions. I don't know what to do with this. I've eliminated the variable. I guess that's a circle. That has to be a circle of radius 3. But who knew? And that's not the way to do it. The first way is the way to do it. So. All right, Griffin. Well, hopefully that helped you a little bit. And enjoy your spring break.
Thanks, you too.
Okay, talk to you later.
Bye.
Bye-bye.